So yeah, well, so I'm going to talk for the next 13, 14 minutes about how big data, AI, open algorithms so could drive sustainable development and democracy. And I'm going to focus on this one. If there's like one message that I want you to like understand or try to get interested in, is this notion of like human AI, human artificial intelligence. Where do I point to this? Where? Okay, all right. So just, well, I'm going to skip a few slides in interest of time, but basically, just by way of introducing myself, so I'm not a data scientist. Like I'm not a computer scientist. I'm not going to tell you my bio, etc. You can look it up. But basically, I come from a development economics background, political science. I'm also a political cartoonist, so I do those kinds of cartoons that I use also in my work. And I was an aspiring journalist at some point. So I was talking to Christophe Deloire about having almost worked for Reporters Sans Frontières in the early 2000s. So I'm very interested in the role of information, like journalism and data, and I try to think about these intersections in my work as a development economist. So the sort of like the context we're all aware of is that there have never been as many data as now in history. At the same time, there are like fake news, echo chambers, fears about big data, Big Brother, surveillance, echo chambers, etc., etc. So it seems like we are at this sort of like inflection point where people are wondering, okay, what should we do? Is data against facts? There is this kind of a discussion going on. So if we try to be more optimistic, also a bit more like productive, we can ask ourselves, how do we make the best of data, big data, AI, like those new technologies, and how can we really think big? And think big is this notion of building human artificial intelligence ecologies, which I will talk about. And you'll see it's actually pretty interesting intellectually and inspiring. Okay, so very quickly, how does AI work? I'm sure you, for instance, you all use Google Maps or you use Google Translate, for instance. So Google Translate is AI. So AI is in a sense, like, as simple as that. So how does AI work? It would take a pretty long time, but I'm going to try and do this in like 30 seconds. So basically, an AI here would be asked, is this picture, is it a beach or is it a city? And if it's a machine, it has no clue at first. So it will take a guess. It will say, it's a city. And then you will say, no, wrong. And you will show it another picture. And you will show it a billion pictures. And you will say, yes, no, yes, no, yes, no. You're right, you're wrong. You're right, you're wrong. Over time, the machine is going to learn the features and the association of features that work, that make it get the right answer, all right? And here I'm saying, through these feedback loops, the machine is learning. And that's the gist of AI. It's machine learning. It's machines learning what works, what helps it get the right result or not. Google Translate is the same. All right? You have a text in Arabic, you translate it into French. At first, you give the machine both the French and Arabic versions, and then over time it learns by like trials the right like sets of paths. So you have this feedback loop. So that's really the gist of AI. So, well, AI it's called AI, artificial intelligence, because it's about like mimicking the sort of like the neural networks that we have in our brains. And in AI, it's called like hidden layers. So it's really those paths, those recipes, those combination of paths and features that help the AI make the right connections between the input data and the output data. And again, the example of Google Translate is a good one. The example of, is it a cat or is it a dog? Over time, these neural networks, these artificial neural networks, ANNs, are going to learn through feedbacks. Okay, so what does it mean? Is it some sort of like black magic? No, but it's a bit like magical, but it's not black magic. So it's been going on for like, for like 60 years, AI. It's still pretty stupid. like AI is still like, pretty stupid. We're not yet at all at a stage where we can think about general AI that will take over the world, etc. These are like they're called like narrow AIs. They're very, very good at doing specific tasks. They are going to get more intelligent, but right now they're still pretty stupid, and humans, for better or worse, are still in control. But the good magic, and that's a very central point, the good magic of AI is what is called the credit assignment function. When I was giving you the example of is it a cat or is it a dog? Is it a beach or is it a city? And then the AI gets it right over time because it's able to understand what are the features and what are the steps that make it get the right answer. So in doing so, it's able to assign credit. It is able to say, what helps me get the right answer is that I'm focusing on this particular color. I'm focusing on this particular like series of there is this and that and this and that. And if I do that, then I get the right answer. If I do another one, if I go another route, then I get the wrong answer. So it's assigning credit to what works. And the key difference, and it reinforces the neurons and the paths that helps it get it right. Okay? The key difference also with 60 years ago is that we have data, lots of data. So it's called big data. All right? But the key principle of AI, the credit assignment function, is not new, but data is new, the fact that we have lots of data. So there have been applications of AI in the field of development. Through machine learning, in particular, we're able to understand poverty levels through cell phone activity. We find correlations between cell phone activity and poverty levels from censuses, from DHS, from surveys, etc. And this is actually an AI system. It's a machine learning system. But more importantly, let me skip that. More importantly, the question is not how we can use those AI, okay, or how we can use machine learning. There are, again, lots of applications where you use machine learning to predict poverty, to predict migration, to infer migration patterns. So lots of examples. But if we think like big, like long-term, big picture, the big picture is this human AI thing. So remember, I can go back here. Okay, remember this, this network. Okay, here it is an AI network. It's what is in a computer. It's Google Translate. Now think of it as this is a society. Okay? This is not just something we're going to use, that we're going to have on our tablet, etc. This is the world. Okay? This is a society. So now think of, all right, so here, think of what would it mean and imply to apply the principles and the tools of AI to entire human societies, to entire companies. It means, how can we, and this is, so in the words of Alex Pentland at MIT, it is, what would happen if you had a network of people, so a society, where you would reinforce the ones, like the neurons, that sort of contribute to a certain desired outcome, and the outcome is not, is it a cat, is it a dog? The outcome is, does it lower poverty, or does it increase poverty? And you apply the same principles and the same tools to entire societies or companies or organizations. So you find what works, and you reinforce those neurons. And the neurons here are people, teams, behaviors, policies, programs. Okay? So this is the human AI. Okay? So it's not about, again, using very narrow technological tools. It's about applying the principles and tools of AI to entire human societies. So it sounds like something a bit, maybe like theoretical, but it's actually, I think, doable in our lifetime. So the key principles are here. The key features are about using the human-machine complementarities, and there are a few requirements and challenges. So let me focus a bit on the challenges. For a human AI to work, there needs to be data, and there needs to be good data. If you have fake news all around, if people do not agree on what is a fact, then it cannot work, or it works very poorly. If we cannot agree on targets, the target variables in your AI system, then it's very hard to make it work. If there is no consensus on the fact that we need to do this for societies to work better, then it cannot work. And indeed, in the world, you have many powerful agents that have no interest whatsoever in having the sort of like better functioning society because they benefit from the status quo. They benefit from bad information. They benefit from bad policies. So it is not in their interest. There is also like analog digital segregation and disdain and distrust that prevents such an AI, like a human AI system, to actually work. Because one thing that is important, and then I'll finish in 4 minutes, one thing that is important is that we know that facts don't change people's mind. It is not by by bombarding people with facts and telling them you don't believe in climate change, you're stupid. All right? It doesn't work. So one of the prerequirements is to build trust and empathy between people such that this system, a sort of like fact-based system, can actually work. So a lot of data that exists in the world today is in the hands and on the servers of private companies. So for this human AI system to work, we need to be able to analyze those data to understand what policies work, what programs work. And right now, it's a big, big, big challenge for privacy reasons in particular. So we developed with a group of the MIT Media Lab, Orange, the World Economic Forum, Imperial College London, Telefonica, and Data Pop Alliance, have developed this project and vision about open algorithms, which is about sending open algorithms to private sector data as opposed to extracting or exposing the private sector data, which is a bad idea. So the data collected by Orange, by here, so the national operator, by MasterCard, we want to be able to mine these data, but never expose them. So we want to ask questions to the data. All right? So questions, and this is the system of OPAL, so which stands for Open Algorithms. So it's about asking questions. For instance, what is the population density in Tunis in real time, based on cell phone activity? There are countries like Senegal, where I was yesterday, that haven't had a poverty survey since 2011. So they have no idea about poverty levels. With something like that, you can get a pretty good estimation of actually what is the poverty level, but also what actually works to decrease poverty. So, and I'm almost done. So we actually, I said it's not a theoretical, it's actually, we're actually actively working to put this in place. So we have 2 pilots right now in Senegal and Colombia with 2 major telecom operators, Orange and Telefonica, and their national statistical offices. Our plan is to expand to 5 to 10 other countries in the next 5 years, including Tunisia. That's one of the, let's say, priority countries or target countries. And this is the last slide. And as I said, it's not a techno-utopian sort of view, a dry technological. It's really about using data to fuel and feed better human systems, using the principles and methodologies of AI to build a sort of human AI where we know what works, what doesn't work. We reinforce habits that do good, and we weaken habits that do not. But key to this, and this is my final remark, is what is called data literacy, or building capacities, connections, building trust, building empathy between people such that people can actually learn how to interpret data, care about facts, and are willing and able to sort of embrace this new world. Because we can train data scientists, we can train computer scientists to do horrible things. And this is what Lévi-Strauss said, or almost half a century ago, that literacy, and I end on this because it's a UNESCO conference, that literacy is actually not necessarily a good thing. It very much depends on what it's used for. So this notion, I will end with this notion of data literacy and how we can build this ability and willingness to constructively engage in society through and about data and information. Thank you.